Every year, 10 million tons of waste end up in the world's oceans, and 80% of this is plastic, which is not biodegradable and harms the entire marine ecosystem. It is insidious. It sinks beneath the ocean surface and stays there lurking, invisible to the naked eye. It is often referred to as the seventh continent. The US captain Charles Moore discovered this phenomenon in 1997 in the Pacific Ocean, where it occupied a vast zone 6 times the size of France. Vortices like this one exist in all 5 major ocean basins. In these huge gyres, currents, influenced by the Earth's rotation and the Coriolis force, inexorably trap all waste materials. The French expedition sponsored by CNES, Mercator Ocean, and the European consortium myocean set off in May 2013 to the 7th continent in the North Pacific's giant subtropical gyre aboard a 48-foot Swan super yacht. The expedition, organised by the French Guiana Association OSL, was led by the sailor-explorer Patrick Dexon, accompanied by a marine biologist, a photographer, videographer, and the American captain. Their aim was to bring back visual and scientific evidence from samples gathered while sailing 2,000 nautical miles, after setting off from Southern California in the footsteps of Charles Moore. By using space data, we know where plastic waste accumulates by tracking the trajectories of Argos beacons over several years as they drift on the same path as waste in these huge gyres. We're also able to locate in real time the zones with the highest probability of waste concentration by employing Mercator ocean forecasting models using data from oceanographic satellites like JASON. Our job is ocean forecasting. We integrate satellite data. We use data that has been observed at sea. We run numerical models representing the ocean in the form of equations. And from all of this, we describe the ocean in real time, with some forecasting, but also hindcasting. All this enables us to explain the ocean's behaviour and find out, depending on the seasons, where to look for the concentration of waste to be observed by the expedition. Other scientists are aiming to better characterize how pollutants are transported by these plastics by means of organoidal sensors in order to assess their impact on ecosystems and the food chain. What impressed me was that as soon as we started to approach the gyre, we found macro waste. We had counted up to 10 per hour, and when you extrapolate that for the 6 million square kilometers that makes up the gyre, that's several million tons of plastic in the North Pacific. And this is only the tip of the iceberg, because when we use the manta net, the plankton net that captures the microparticles of plastic, well, then we reveal this plastic soup that fills the spaces in between. Young people feel concerned by this terrible ocean pollution and want to prevent it. As part of the educational project Argonautica, students worked on data from Argos beacons to try and understand ocean circulation and the accumulation of waste in the gyres, while others built the gyroplastic buoy, which assesses the amount of plastic below the surface. There is still much to learn from future expeditions. Scientists specialized in space research, operational oceanography, and chemistry still have much to contribute by helping to locate, observe, and describe this global ecological disaster. The most recent initiatives are already raising awareness and inspiring brilliant inventors to find solutions. This pollution is not inevitable. We can all help to stop it. Think twice before throwing plastic into streams, rivers, seas, or on the beaches.